So in this video, we are going to be looking at the topic further logarithms. So basically, we know that logarithms stem from indices. So a general index point, in case we have got a to power b being equals to c, we know that now in this case, a is going to be the base, b is going to be the power, or what we call the index, in other words, and c now is our solution. So from the index form, we can be able to change from the index form into logarithmic form now. So when we change into logarithmic form, we shall say that now here we are having the log the base a of c being equivalent to b. Maybe on a practical scenario, if we have got, for example, 2 to power 3, which we know is equivalent 8, in logarithmic form, this shall be the log to the base now here, which is 2, of our solution 8 being equals to 3. Maybe you can just try on a piece of paper. If you have got now 4 to the power 3, which is equivalent to 64, we change this now into logarithmic form. So when you change this into logarithmic form, this is going to be the log to the base 4 of 64 is now equivalent to 3. You're also going to realize that if, for example, you have got same numbers, for example, the log to base 2 of 2, this is going to be now equivalent to 1. Because what you're going to be asking yourself is, what do I raise the base here, which is 2? To what power do I raise 2 to, so that I can be able to get the solution 2? You're going to realize that it is going to be 1. If, for example, you have got the log to the base of 5 of 25, here you're going to be asking yourself, if the base is 5, what do I raise 5? What power do I raise 5 so that I can get 25? You're going to realize that this is equivalent to 2. So that way now, you have been able to transform from index form into logarithmic form. So from there now, we look at the laws of further logarithms, and we look at the first law is whereby we are multiplying the numbers. So for example, if you have got the log of a multiplied by b, this is going to be equivalent to, now since the logs are indices, when we multiply the numbers, we sum the indices. So this is going to be equivalent to the log of a plus the log of b. Then number 2, in case now we are dividing the numbers, if we have got the log of a all over b in indices, when we divide the numbers, we subtract the indices. So in this case, we are going to have the logarithm of a, we take away the logarithm of b. Then number 3 is whereby now we have got a power. For example, if we have got the log of a raised to power n, this is going to be equivalent to, in indices now, when a number is raised to a certain power, we multiply the two powers. And so in this case, we shall have this being equivalent to n multiplying the log of a. And so these are the first 3 laws of logarithms that now we require to know or to identify with, so that now we can be able to solve questions with. So now here, in our first question, we are told that we simplify the following expression without using mathematical tables or a calculator. So our expression is 3 log to base 10 of 4 plus the log to base 10 of 125. We take away 3 log to base 10 of 2. So we just refer to the laws of other logarithms, and then now we can be able to apply those laws in order we can be so that we can be able to simplify this expression. So how do we do it? So we take the first part here. When you look at the first part, here you're adding the logarithms. So this means that the numbers are being multiplied. So you reverse, and we know that the first value there is going to be the log at base 10 of 4 to power 3, since the log is multiplied by the coefficient 3. And then this is going to be plus the log to base 10 of 125. And then we take away the log to base 10 of 2 to power 3. And so now, after that, we can be able to combine all these into a single log. So this is going to be the log to base 10. Please note, you can only combine the three logs into a single log if and only if the bases are the same. For example, in this case, the base is throughout 10, 10, 10, 10. So since the base is 10, we can be able to combine the three into a single log. But the laws of further logarithm only apply when the bases are the same. So in this case, we are going to combine these. So we take 4 to power 3 multiplying 125, since the two logs were being added. Then all these we divide by the subtracted log, which is now the number is 2 to power 3. And so now, in this case, we know that this is going to be the log to base 10. 4 to power 3 is 64. So we multiply by 125, and then we divide by 8. And so consequently here, we can be able to simplify the number. So we take by 81 by 88, and when you multiply 8 by 125, it's going to be equivalent to 1,000. And so here, we ask ourselves, what do we raise 10 to so that we can be able to obtain 1,000? And we know that we raise 10 to power 3 in order to get 1,000. So the log to base 10 of 1,000 is going to be equivalent to 3. So this means we have simplified our expression to being equals to 3. So our second question is quite similar to the first question. We have also been told simplify the following expression without using mathematical tables or a calculator. And the values that we've been given is 3 log to the base 2 of 4 plus log to the base 2 of 108. We take away 3 log to the base 2 of 6. So similarly, using the three laws that we identified, we rewrite this, and this is going to be the log to the base 2 of 4 to power 3, and then plus the log to the base 2 of 108, and then we take away the log to the base 2 of 6 to power 3. And now, using the laws of further logarithms, we know that when the logs are being added, this means that the numbers are being multiplied, and we check that the base for all the logs here is the same. So since the base is 2 throughout, then this means we can be able to combine all these into a single logarithm, and this single logarithm, the base is going to be 2. So we take now 4 to power 3 multiplying 108, and then divided by the subtracted log, whereby the subtracted log, the number is 6 to power 3. And so consequently, this is going to give us the log to the base 2. So put in brackets 64, we multiply by 108, and we divide all that by 216. And so here, we can be able to simplify the number. So when we simplify the number, we know that by 8, this is going to give us 8. And here by 8, this is going to give us 27. We simplify further. We say by 27 1 to 108 by 27, we get 4. And so consequently, this is going to be equivalent to the log to base 2 of 32. So we simplify further, since we know that the log to base 2 of 32 is going to be equivalent to, so you can just pause there and first of all check that what do we raise to the what power do we raise 2 to in order to gain 32? And the answer here, you're going to find out that it is going to be equivalent to 5. So this means we have simplified our expression into now our final answer, which is 5. So in our third question, we have been told that we find the value of x given that the log to the base of 2 into bracket x squared minus 2, we take away the log to the base 2 of a half x plus 5, and then we take away a constant 1 is equals to 0. So now here, the first step that we're going to do is we take the 1 onto the other side. So that's now on the left-hand side, we shall be left with the numbers with the logarithms only. And so when we do that, we are going to have the log to the base 2 x squared minus 2 minus the log to the base 2 half of x plus 5 is now going to be equivalent to a positive 1. So now on the left hand side, we can be able to collapse the two logs into a single log. And since the base is the same, then the laws of further logarithms apply. So when we collapse this into a single log, we're going to have the log to base 2 of now x squared minus 2 divided by half x plus 5. And this is going to give us now positive 1. So this way now, we have been able to collapse everything into a single log. And in order to solve for x, we now need to change from logarithmic form into index form. So to change into index form, the base is 2. So we say that 2 raised to the power 1 is now going to be equivalent to our solution, x squared minus 2 all over half x plus 5. And now from here, we can be able to solve the equation in order to obtain the value of x. So when we multiply both sides with our denominator, we are going to obtain twice in brackets half x plus 5 being equals to x squared minus 2. And so now the left hand side is going to give you x plus 10 being equals to x squared minus 2. So then we can be able to rearrange this into a quadratic equation, whereby when we rearrange, we are going to get x squared minus x minus 12 is equals to 0. So from here now, we solve the quadratic by, first of all, we can use any of the methods, but here I prefer we use the factors method since it is easily applicable. So we look for two factors whereby their product is going to be equivalent to our AC, and in our question here, our AC is negative 12, and then the sum of the two factors is going to be equivalent to negative 1. So these two numbers are going to be negative 4 and positive 3. So we insert them into our equation. So when we insert them into our equation, it is now x squared minus 4x plus 3x minus 12 is equals to 0. So from there, we can pair the two. So the first pair, we factor out the common factors. The common factor there is going to be x. So we say x in brackets x minus 4, and then plus the common factor in the second pair is going to be 3. So we factor out 3, and in brackets we have x minus 4. And all that shall be equals to 0. Then from there, we can combine the two so that we have x plus 3 in brackets, x minus 4 in brackets is now going to be equivalent to 0. So from there, we can conclusively say that it's now x plus 3 is equals to 0, or x minus 4 is equals to 0. And now from there, we can solve for the value of x so that we can obtain that x is going to be equals to negative 3, or x is going to be equivalent to positive 4. And so that way, we have been able to completely solve for the value of x. So in our fourth question, we have been told solve for x in 3 log to the base of 3x plus 4 is equals to the log to the base 3 of 24. So here clearly we know that the first value here is going to be the log to base 3 of x cubed from the laws of further logarithms. So we rearrange this equation such that now all those values with the logs, we take them to the same side. So we're going to have the log to base 3 x power 3 minus the log to base 3 of 24. So I have simply taken the log to base 3 of 24 to the left-hand side so that it has become negative. And then now you take the 4 to the right-hand side so that it becomes negative 4. So that way now you can be able to collapse the left-hand side into a single log. So when we collapse it into a single log, we are going to have the log to the base 3 of now x cubed. And since the logs are being subtracted, this means that the numbers are being divided, so that now this becomes negative 4. So from there now, we can be able to change from logarithmic form into index form, so that now we can be able to solve for the value of x. So this is going to be x all over x cubed all over 24, being equivalent to 3 to power negative 4. And then we know that 3 to power negative 4 is equivalent to 1 all over 81, since it is 1 all over 3 to power 4. And so in this case now, we are going to have x cubed being equivalent to 24 out of 81. And now simply, so that we can be able to get the value of x now, we first of all simplify 24 out of 81. So when we divide 24 by 3, we get 8, and 81 by 3, we simply get 27. And then from there, to get the value of x, we can be able to cube root the value 8 out of 27. And since these ones are perfect cubes, when we cube root, we are going to obtain 2/3. And so the value of x in this question now is 2/3. So in our fifth question, we have been told that given find without using log tables or calculators the value of x which satisfies the equation the log to base 3 in brackets x squared minus 9 is equivalent to 2 log to base 3 of 3 and then plus 1. So in this scenario, uh, when we are given these values, we specifically look at the right hand side where we have got 2 the log to base 3 of 3. So we know that this value, the log to base 3 of 3, is equivalent to 1. And so consequently, 1 times 2, we get 2. So the whole of the right-hand side is going to be equivalent to 3. So this means our equation is now the log to base 3 into brackets x squared minus 9 being equals to 3. And so now from there, since we only have one log, now we can be able to change from logarithmic form into index form. And so now when we change into index form, we are going to have x squared minus 9 being equivalent to 27, which is now our base 3 raised to our index, which is also 3. And so in this case, we are going to have x squared being equivalent to 36. So in order to solve for x now here, we find the square root on both sides. And so the value of x is going to be equivalent to the square root of 36, which must be now plus or minus. And we know the square root of 36 is now plus or minus 6. And so in that case now, we have been able to get our value of x as either positive 6 or negative 6. So in our sixth question, we have been given that the log of x to base 10, put in brackets squared, is equals to 3 minus the log to base 10 x squared. So now here, something that I want us to realize is that we cannot open the bracket whereby we have got the log to base 10 of x squared. So that bracket needs to remain intact as it is. But now, on the right-hand side, we can be able to change the log to base 10 x squared to now become 2 log of x. So on the right-hand side, we can have 3 minus 2 log to the base of 10 of x. And so consequently, we can be able to rearrange our equation so that now we have the log to the base of 10 of x, put in brackets all of it squared, and then now plus 2 log to the base of 10x when we remove it from the right-hand side to the left-hand side. And then now we take away 3. So 3 becomes negative when it comes to the left-hand side. And now all this is going to be equivalent to 0. So as I had said before, that we cannot be able to open up the brackets where we have got the log to base of 10 of x, all of it squared. So here we need to be more inventful. So what we do, we let the log to the base of 10 of x to be equivalent to p. So we let the log to the base of 10 of x to be equivalent to p, and we substitute that p into our equation. So when we substitute p into our equation, we are going to have p squared plus 2p minus 3 is equals to 0. So that clearly shows us that our equation now is a quadratic equation. So as usual, we solve the quadratic equation by getting two factors. Here we are going to have 3 and negative 1. We pair them, and then we'll be able to solve that quadratic equation such that now we are able to obtain the values of p. So we obtain the values of p now here to be p is equals to 1 and p is equals to negative 3. But now we need to remember that we had made the value of p to be the log to base 10 of x. So since we had made the value of p to be the log to base 10 of x, so we say that the log to base 10 of x is equals to now 1, or the log to base 10 of x is equivalent to negative 3. And now at that point, we can be able to convert from the logarithmic form that we are in into index form, so that now we can be able to get the value of x. So the first case, we are going to have 10 to the power 1 being equivalent to x. And then the second case, we are going to have 10 to the power negative 3 being equivalent to x. And so now we know when 10 to the power negative 3 is equivalent to x, x shall be equals to 0.001, which is the same as 1 all over 1,000. And now here also x is equivalent to 10. So our x has got two values in this context, that is 10 and 0.001. So in our seventh and last question, we have been asked to solve for x in the equation the log to base 3 of x put in brackets squared. Then you take away a half of the log to base 3 of x being equals to 3 all over 2. So here now, the first thing we do is we rearrange this equation such that we just bring 3 all over 2 to the left-hand side, so that now it becomes negative 3 all over 2, and the right-hand side we have a 0. So you realize that in this context we have a similar case to question 6, whereby we have got a log put in brackets and it is squared. So this means we cannot be able to open up the bracket. So what we do is we let the log to base 3 of x to be equivalent to an algebra. For example, here we use p. So when we let the log to base 3 of x to be equals to p, we substitute the p into the equation, so that now we have p squared minus a half p minus 3 all over 2 is now equals to 0. And so in this case now we have a quadratic, whereby we multiply by 2 on the left and also on the right. We are going to have 2p squared minus p minus 3 is equals to 0. So in this case we form a quadratic whereby we solve the quadratic. So to solve the quadratic, we look for two factors, whereby now we are going to fit them in, and then we can be able to find the values of p. And so here we are going to have 2p squared plus 2p minus 3p minus 3 is equals to 0. And so here, when we solve the quadratic, we simply get 2p minus 3, p plus 1 is equals to 0. And so consequently now, our p is going to be equivalent to 3 over 2, or our p is going to be equivalent to 1.5, or also our p now here is equivalent to negative 1. But now, we remember that this value of p is what we let to be the log to base 3 of x. And so we substitute back the log to base 3 of x to be now equivalent to 1.5. And we also now let this value, the log to base 3 of x, to be equivalent to negative 1. So this means that when we change from logarithmic form to index form, we are going to have 3 raised to power 1.5, which is equivalent to 5.196 to 4 significant figures, or otherwise it would have been 3 root 3. And when we have got the log to base 3 of x being equals to negative 1, this is equivalent to having now 3 raised to power negative 1, which is the same as 1 all over 3 to power 1, which is equivalent to that. So that way now we can conclusively say that the values of x are going to be 5.196, or the value of x is going to be that. So that way now we have been able to conclusively solve for the value of x.